Okay, this is a dilution problem in which a reaction occurs. And you can recognize these problems because a net ionic equation is given to you. Now, what happens physically is that as this reaction proceeds, ions are removed from solution. And we're going to solve them using BCA, or before, change, after tables. And these are the steps we're going to be working through. And a BCA table is essentially a means of keeping track of things. It's just a tool. Now, in each of these locations, you would be putting the number of moles of barium before, the amount by which barium 2+ changes, and how much is left after the reaction is complete. The same is true for the sulfate. We want to calculate the initial number of moles of each of these reagents, which are these two ions, barium and sulfate. Here are the dissociation reactions for the two salts, and we're only going to be paying attention to those ions that are actively involved in the reaction. So that would be the barium and the sulfate. And luckily enough, what we see here is that there's a 1-to-1 mole ratio between the salt and the ion that's involved in the reaction. We see here in each case there's a 1-to-1 mole ratio between the salt and the ion that's involved in the reaction. All right, so we've done our calculation to determine the number of moles initially of barium 2+ and moles of sulfate ion. And we can put these values into our BCA table on the before. So initial moles of barium 2+, 0.40, and for sulfate, 0.60. Now, as these react, they react completely until one of the reagents is consumed. And we can see by inspection here that the barium is going to be the limiting reagent. Okay, that's because it's a 1-to-1 mole ratio, and there's less barium than there is of the sulfate ion. Now, all of the limiting reagent is going to be consumed. So the final amount of the limiting reagent, in this case barium, is going to be 0, which means that 0.40 moles of barium have been reacted. Since this is a 1-to-1 mole ratio, we're also losing the same amount of sulfate ion. So after the reaction, we have 0.20 moles of sulfate left and 0 moles of barium. All right, let's recap where we are. We're recognizing that as the reaction occurs, the ions are removed from the solution. And we've calculated the moles of each reagent. Here, each ion, put those values into the BCA table. Identified the limiting reagent, and since this is a 1-to-1 ratio, it's going to be the reagent that has the least number of moles. And we recognize that the final concentration of our limiting reagent, barium, is going to be 0.0 moles per liter. And we've determined the amount of the excess reagent that remains unconsumed by subtraction. And as a final step now, we can calculate the final concentration of the sulfate ion. So the final concentration of the sulfate ion is going to be the moles of sulfate, which is 0.20 moles, divided by the volume of the new solution, which is obtained by adding the two solutions together. So that's 0.300 liters, and we do the division, 0.6666 moles per liter. We can justify 2 sig figs, so this is 0.67 moles per liter.